Hello students, this video is about question and answers of the class 6th science chapters.
Chapter 13 Fun with Magnets. Exercises. First main A. Multiple choice questions. Here you have to select the correct option. First question is the magnetic strength of a magnet. The given options are A is uniform throughout the body of a magnet. B is concentrated at one point called the pole of the magnet. C is concentrated in two regions called the poles of the magnet. D is concentrated in the center of the magnet. Here the correct answer is option C, that is concentrated in two regions called the poles of the magnet. The magnetic strength of a magnet is concentrated in two regions. Those are North Pole and South Pole. Second question. Which of the following is not a magnetic material? Options are A. Gold, B. Nickel, C. Iron, D. Cobalt. Here the correct answer is option A. Gold. It is not a magnetic material. Third question. Materials attracted by a magnet are called option A. Diamagnetic, B. Leading stone, C. Magnetic materials, D. Non-magnetic materials. Here the correct answer is option C. Magnetic materials. Materials attracted by a magnet are called magnetic materials. Fourth question. A compass is used for option A. Alignment along north-south direction, B. To find direction in the sea, C. To attract magnetic materials, D. None of these. Here the correct answer is option B. To find the direction in the sea. Compass is used for to find the direction in the sea. Fifth question. When two substances repel each other, then the given options are A. One of them must be a magnet, B. Both of them must be magnets, C. One of them must be non-magnetic, D. Both of them must be non-magnetic. Here the correct answer is option B. Both of them must be magnets. When two substances repel each other, then both of them must be magnets. Sixth question. A magnet will lose its property if it is option A. Dropped, B. Put in water, C. Cut into pieces, D. Kept in a refrigerator. Here the correct answer is option A. Dropped. A magnet will lose its property if it is dropped. Seventh question. We can magnetize a magnetic material by using the given options are A. Torch, B. Cell, C. Magnet, D. Bulb. Here the correct answer is option C. Magnet. We can magnetize a magnetic material by using a magnet. Eighth question. A device consisting of a small magnetic needle used to find directions on the Earth's surface is called A. Magnetometer, B. A magnet, C. A magnetic compass, D. A pathfinder. Here the correct answer is option C. A magnetic compass. A device consisting of a small magnetic needle used to find directions on the Earth's surface is called a magnetic compass. Ninth question. In which of these shapes we can have a magnet? Option A. Ring, B. Bar, C. Horseshoe, D. All of these. Here the correct answer is option D. All of these. In which of these shapes can we have a magnet? In ring, bar, horseshoe, in all of these shapes we have a magnet. 10th question. When two magnets are brought close together. Option A. like poles attract and unlike poles repel each other. B. Attraction or repulsion depend on the orientation of the magnets. C. Like poles repel and unlike poles attract each other. D. Attraction or repulsion depends on the shape of the magnets. Here the correct answer is option C. Like poles repel and unlike poles attract each other. When two magnets are brought close together, like poles repel, whereas unlike poles attract each other. Second main, B. Fill in the blanks. First question. A magnet, no matter how big or small, will always has dash poles. A magnet, no matter how big or small, will always has two poles. Second, the phenomena of attracting iron and pointing in north-south direction is called dash property. The phenomena of attracting iron and pointing in north-south direction is called magnetic property. Third, iron and nickel are dash materials, whereas copper and aluminium are dash materials. Iron and nickel are magnetic materials, whereas copper and aluminium are non-magnetic materials. Fourth, if a magnet is heated or handled roughly, it loses its dash. If a magnet is heated or handled roughly, it loses its magnetism. Fifth one, a magnet always comes to rest in the dash direction. A magnet always comes to rest in the north-south direction. Sixth one, a magnetic compass has a dash at its center. A magnetic compass has a magnetic needle at its center. Third main, C. State true or false against the following statements. First one, a compass can be used to find east-west direction at any place. So this one is true. Second one, bar magnets when suspended freely always point towards north-south direction. This is also true. Third, similar poles of a magnet repel each other. This is also true. Fourth, rubber is a magnetic material. This is false. Fifth one, magnetization is the process by which a magnetic substance is changed into a magnet. This is also true. Sixth one, magnetic poles never exist in pair. False. Seventh one, magnetite, an iron ore, is an artificial magnet. False. Eighth one, a piece of iron attracts magnet. A piece of iron attracts magnet. False. Ninth one, copper is a non-magnetic substance. True. All magnets have directive property. True. Fourth main, D, match the items of column A with those of column B. Here in the column A, it is given as magnetite, magnetic compass, nickel and cobalt, non-magnetic substance, natural magnet, magnetic poles. So here you have to match with the column B. Here magnetite is a dark colored ore of an iron. B, magnetic compass. Magnetic compass is used in navigation for indicating direction. Nickel and cobalt are magnetic substances. Non-magnetic substance is paper. Natural magnet, lodestone. Magnetic poles exist in pairs. Fifth main, E, differentiate between natural and artificial magnets and magnetic and non-magnetic substances. Answer. First we will see differences between natural magnets and artificial magnets. Natural magnets are lodestone or leading stone, whereas artificial magnets are man-made magnets. Artificial magnets are man-made magnets. In the natural magnets, these have very weak magnetic strength. In artificial magnet, these have stronger magnetic strength in comparison to natural magnets. Now the difference between magnetic substances and non-magnetic substances. In the magnetic substances are attracted by the magnets. In the non-magnetic substances are not attracted by the magnets. Example of magnetic substances are iron, cobalt, nickel, whereas examples of non-magnetic substances are aluminium, plastic, etc. Next main, F, give reason. First question, repulsion but not attraction is a sure test of magnetization. Answer, an attraction can be caused either by opposite poles of magnets or between one pole of the magnet and an unmagnetized bar or iron. But a repulsion is the surest test of magnetism, as repulsion occurs only between the two similar poles of magnets. Second question, to store magnets, magnetic keepers are used. To store magnets, magnetic keepers are used. Answer, magnets tend to become weaker after some time if their poles are left free. So magnetic keepers are used to store magnets safely. Third question, magnetic poles exist always in pair. Magnetic poles exist always in pair. Answer, a magnet has two poles. Two poles of any magnet cannot exist independently. They remain in pairs. If a bar magnet is broken into two pieces, then each piece behaves as a whole magnet. Fourth question, a freely suspended magnet points in the north-south direction and not east-west direction. A freely suspended magnet points in the north-south direction, not in the east-west direction. Answer, a magnet has two poles as north pole and south pole, which always follow the south pole and the north pole of Earth respectively. Thus, a freely suspended magnet comes to rest in the north-south direction. Next main Z, very short answer type questions. Here first question is, what is a magnet? What is a magnet? Answer, magnet is an object that attracts materials like iron, cobalt and nickel, etc. Second question, what is a magnetic substance? What is a magnetic substance? The substances which are strongly attracted by a magnet or can be converted into a magnet artificially are called magnetic substances. Third question, define the term non-magnetic substance. Define the term non-magnetic substance. Answer, non-magnetic substances are those substances which neither attracted by a magnet nor can be converted into artificial magnets. Fourth question, how many poles does a magnet have? How many poles does a magnet have? A magnet has 2 poles as North Pole and South Pole. Fifth question, name 2 characteristic properties of a magnet. Answer, the 2 main properties of a magnet are its attractive and directive properties. Attractive and directive properties. Sixth question, what are the 2 types of a magnet? What are the 2 types of a magnet? The 2 types of magnet are natural magnet and artificial magnet. Next main H, short answer type questions. Here first question is, state the important properties of a magnet. Why is the study of magnetism so important? State the important properties of a magnet. Why is the study of magnetism so important? Answer, the 2 main properties of a magnet are, it attracts small pieces of iron towards itself. A freely suspended bar magnet always points in the north-south direction. A magnet is used to find the direction in different places on the earth and also in other useful electronic items as computer, television, MP3 players, music system, etc. So the study of the magnet is very important to understand the uses and functions of the above items properly. Second question, what are the differences between iron and aluminium? Answer, iron is a magnetic substance while aluminium is a non-magnetic substance. Third question, one precaution you should always take while handling a magnet is not to drop it. Why? One precaution you should always take while handling a magnet is not to drop it. Why? Answer, a magnet can lose its properties by dropping it from a certain height. Fourth question, how can a magnet lose its properties? Write any 3 ways of losing it. How can a magnet lose its properties? Write any 3 ways of losing it. Answer, a magnet can lose its properties by 3 ways as first one, by hammering the magnet. Second, heating the magnet above a certain temperature. Third, dropping a magnet from a certain height. So these are the 3 ways so that magnet lose its properties. One is hammering, second one is heating, third one is dropping of a magnet. Next main I, long answer type questions. First question, describe with the help of an experiment that a freely suspended magnet comes to rest in the north-south direction. Describe with the help of an experiment that a freely suspended magnet comes to rest in the north-south direction. Answer. Here materials required: a magnetic compass, a powerful bar magnet, a thread, a base, table and chalk. So these are the materials required. Method: mark north, south, east, west directions with the help of magnetic compass on the base table with the chalk. Now suspend a bar magnet from a base with the help of a thread as shown in the figure. So here east, west, north, south directions are mentioned on the base of the table, and this one is the suspended bar magnet. You will notice that one end of the bar magnet is pointing towards the north and other end towards the south. Now turn the bar magnet through 90 degree and allow the magnet to come to rest. What do you observe? You will notice that the magnet again comes to rest in north-south direction. Thus, the conclusion is that a freely suspended magnet comes to rest in the north-south direction only. Second question. State the characteristics of a magnet. Name the poles of a magnet. How can to ascertain the polarity of a magnet? Can poles be isolated? State the characteristics of a magnet and name the poles of a magnet. How can to ascertain the polarity of a magnet? Can poles be isolated? So we will see the answer for all these questions. First, characteristics of a magnet. It attracts small pieces of iron towards itself. This is called attractive property. Second, a bar magnet always points in the north-south direction. This is called directive property. A magnet has two poles as north pole and south pole. There is an experiment to ascertain the polarity of a magnet. Aim to find the poles of a magnet. Requirements: iron nails, sheet of paper and bar magnet. Procedure: place a sheet of paper on the table or on the floor. Spread some iron nails on the sheet of paper. Roll a bar magnet on this sheet of paper and lift it up. What do you find? You will find that the iron nails are sticked more near the regions close to ends of a bar magnet. Here, what conclusion you can draw? From this activity, you can conclude that magnetic force is the strongest at the two ends of a bar magnet. Hence, these ends are called its poles. The two poles of a magnet can never be isolated. Two poles of a magnet can never be isolated. Third question. Give a step-by-step method which you will adopt to test if a piece of magnetic material is a magnet. Answer. First requirements are bar magnet and bar of magnetic material. Procedure. Take a bar magnet, bring the north pole of it near pole of bar magnet of magnetic material and observe what happens. We find that north pole of magnetic bar attract the bar of magnetic material. Now interchange the pole of magnetic bar and do the above procedure, what do we find? We find that bar magnet repels the similar pole of a magnetic material. Conclusion: as the repulsion is a surest test of magnetization, thus the material is a magnet. Next main J, diagram based questions. First question: which of the given poles of magnets will repel each other? Answer: north pole of first one and north pole of second magnet both will repel. Even the south pole of first magnet and south pole of second magnet will also repel. North and north, south and south poles will repel each other. Second question: Sohan has a small piece of metal and a thread. To find whether a piece is a magnet or not, the given options are: requires a piece of magnetic substance, B requires a piece of non-magnetic substance, C requires a magnet or a compass, D does not require anything else. Here the correct answer is option D, does not require anything else. Third question: a bar magnet is cut into two pieces as shown below. What will be the configuration of the poles of the two pieces? Here a bar magnet is cut into two pieces as shown in the figure below. What will be the configuration of the poles of the two pieces? Answer: whenever the bar magnet is cut into two pieces, so answer is shown here. Again it will form a north and south poles. Next main K, HOTS questions. First question: a magnet is broken down in many pieces. How will you determine their north and south poles? Answer: when a bar magnet is broken down into many pieces, each piece behaves as a whole magnet. It means new pole, that is opposite in nature, has been produced the moment when it is cut into two pieces. Second question: why are the bar magnets kept in pairs with their unlike poles on the same side? Answer: magnets tend to become weaker after some time if their poles are left free. So bar magnets are kept in pairs with their unlike poles on the same side. Next main L, value based question. Here Priya was rolling a bar magnet in a fine sand. She pulled out magnet from the sand and noticed grey particles sticking on the ends of the magnet. However, no particles were sticking in the middle of the magnet. She wanted to know the basic facts about it. So, she shared her observation with her father. Being a science graduate, her father clarified such observation with basic facts. Answer the following questions based on the above information. Here, first question is: what are the values displayed by Priya in sharing her observation with her father? Answer: it is about the critical thinking, curiosity and problem solving. Second question: why are these fine particles sticking at the ends of the bar magnet but not in the middle of the magnet? Why are these fine particles sticking at the ends of the bar magnet but not in the middle of the bar magnet? Answer: magnetic force is the strongest at the poles. Magnetic force is the strongest at the poles of a magnet. So, fine magnetic particles are sticking at the ends, that is poles of the bar magnet. Magnetic force is strongest at the poles of a magnet. So fine particles are sticking at the ends of the bar magnet.